Okay, so today we're going to be talking about solving quadratics by factoring. And we've solved quadratics by graphing, and that is really a good method. However, you don't always want to graph. And so a second and a really good method is if your equation will factor, well then factoring and then solving it that way is going to be really helpful. Now, on your quiz the other day, I noticed some people had like an x squared, plus like say 6x, plus I don't know, 5 equals 0. And they solve this, they try to solve it by subtracting the 5 and trying to solve for x. But the problem is you cannot subtract the 5 and solve for x if there's both an x squared and an x in your equation. You could graph it, but you can't solve it algebraically if it has x squared and x in this manner. And so one method that I'm going to teach you today is if you factor it, it makes it less of a difficult problem. It's a little bit easier to say, okay, I can take the portions of it, breaks it into kind of two parts, two factors who you can solve easier. And so the first one we're going to look at would be number 1. And I think the big thing would be, if you factor this, you can't solve it algebraically. You could graph it and put a y here and see where it crosses the x-axis to look for the real solutions. But factoring is going to be a good move. So if you take x times x to get x squared, and you need to be able to multiply this together, to make positive 12. So the last times the last makes the last number right here. And then this rainbow has to make the middle term. So if you multiply the rainbow, you get negative 6x. If you multiply this rainbow, you get negative 2x. And together they make negative 8x. So if your two factors multiply back to make your original problem, you're allowed to substitute that in its place. And that will help you to be able to solve this quadratic equation. Well, the way that you do that is get everything to one side, factor it up, and then you set each of your factors equal to 0. Why? Well, when you were little learning multiplication facts, you learned that if you times two factors together, and you get 0 as an answer, one of those has to be 0. And so you set each factor equal to 0 and solve it. Okay, and so this would be plus 2 to both sides. You get x equals 2. And then if you do this one, or, okay, the proper thing is to put or between them. You put x minus 6 equals 0. Add 6 to both sides, you get x is equal to 6. So your answers are 2 or 6 should work in the original problem. What do you mean? Well, if you plug in 6 to the top problem, you get 36 minus 6 times 8 is 48. So it's 36 minus 48, and then add 12. That should give you 0 as an answer. Also, if you plug in 2 squared is 4, 4 minus 8 times 2 is 16, so 4 minus 16, and then add 12, that also should give you 0. So you factor it and set each factor equal to 0 to find the answer. So based on your factoring skills, we're looking to do that. Okay, so the next one again should be factor. You cannot solve it algebraically, and so we want to factor it into two parentheses, and then you'll set each of those equal to 0 because a factor times a factor equaling 0, one or the other has to be 0. So x times x gives us the first number, x squared, and then the product of the last has to be the end. So 7 times 8 makes that. Two positives will work fine. And then you have to check the rainbow. If you multiply the outer and inner rings, you're going to get 8x and 7x. And then together they do make 15 in the middle. So you must check the rainbow to see when you remultiply the parenthesis back, does it actually work? Is it actually true? And once you're done with that, you set each parenthesis equal to 0, each factor equal to 0 and solve it. You get x equals negative 7. And then the second one, x plus 8 equals 0, and subtract 8 from the sides, you get x equals negative 8. So that'll be the other answer. So one or the other could be used to solve it. So you've got to show both of them. Those are your options for solutions to this problem. The last one, again, you've got to make things all on one side. So subtract 24. So you get x squared plus 5x minus 24 equals 0. If you factor this into two parentheses, x times x makes your x squared. 3 times 8 is 24, amongst other things. But because we want the middle to be positive 5, you want to do negative 3 and a positive 8. The product of the first has to make the first answer. The product of the last has to make the last. And then the rainbow, multiplying inside there, like foiling this out, it has to be true to the original problem. So you get 8x and negative 3x, and together they do make positive 5x. So set each factor equal to 0. So x minus 3 equaling 0. You add 3 to get 3 as an answer. And the other one would be x equals negative 8. So those would be the solutions to number 3. Number 4, okay, we're going to have a coefficient in front of x squared. So this brings up the level of difficulty a smidge. And so we're looking to say, Can we factor this? Well, the product of the first two factors, the first two items within each factor have to multiply to make the first term. And so 7x times x really is your option. Okay, you could do x times 7, that doesn't matter. Either one would be fine. And because when the first term is prime, it makes it easier. Now, the last number being 6, there are options. Okay, and so I want you to think about this. If I make this last one to be 1 times 6, that's an option, 2 positives. Because 1 times 6 is 6. Well, if you do the rainbow, you're going to get 42x and you're going to get 1x. Well, that's a problem. This doesn't make 23, does it? Okay, and so I want you to think about, when you have options, work with it until you get the ones that make the rainbow to be that. Now, if you do not the opposite, but instead of 6 times 1 or 1 times 6 and you did 6 times 1, honestly, that makes 7x times x is 7x squared. 6 times 1 is 6. But if you do the rainbow, you get 7x and you get 6x, which gives us what? 13x. So it's a different rainbow if you switch those factors and there happens to be a leading coefficient. So just be alert. 1 times 6 is not the same as 6 times 1 when you have a leading term. Okay, so, well, neither of those work. So let's try yet another one. Let's try 2 times 3 or 3 times 2. It's probably going to be one of those. And so, if you're good at kind of mentally doing this, you might know already which one is correct. Okay, and so again, when it multiplies back to make it, you found it. It is going to be 2 times 3. How do I know that? Well, because 7x times x is 7x squared, 2 times 3 is 6. That's true. 7x times 3 is going to be 21x, and 2 times x is 2x. Put those together, you get 23x. Okay, and so that's going to be your answer. If you had done 3 times 2, it would not work. Okay, set each factor equal to 0 and solve it. So 7x plus 2 equals 0. Subtract 2 from both sides, and then divide both sides by 7. You're going to get negative 2/7. I did that verbally because I don't have a lot of space. And this is going to be subtract 3 from both sides. You get x is equal to negative 3. So I would say pause the video and see, can you factor the next two problems into these two parentheses, and then join me in a minute. Okay, check to see, can you do these? To get to x squared, 6x squared, you might think, I'm going to try 6x and x, and you can try it. But guess what? You can try 15, which would be 1 times 15 or 15 times 1. It could be 2 times 3 or 3 times 2. I don't think either one of those are going to work. Okay, and so you can try 6x and x and then pair up the 15 in terms of whatever you think is going to help. And the truth is that, quite honestly, none of those are going to work. And so if none of them work and make negative 1x in the middle, well, then maybe you should try 3x and 2x to get to 6x. And so let's try 3 times 5. And because you want to multiply to make a negative 15, you need 1 negative, 1 positive. I don't think this is going to work, but let's check. If you do 3x times 2x, you get 6x squared. If you do 3 times negative 5, or negative 3 times 5, you get negative 15. Let's check our rainbow. You get 15x and then negative 6x. Yeah, look at that. 15 minus 6 is not negative 1x, is it? Okay, and so if you had just gotten the right number, like 1x instead of negative 1x, you would just flip the signs of those two values. So let's try flipping this to make it 5 and then times 3. The eraser on this thing is just horrifying. So I'm going to try to erase and see if I can make it go, but it doesn't go very fast. So here we go. So again, I made this to be 5 and 3, so I'll make a better 5 if I can. Okay, so if this is 5, okay, so let's try. 3 times 2x is 6x squared. Negative 5 times 3 is negative 15. Okay, I'll check our rainbow. This is 9, okay, x, and this right here is negative 10x. Ooh, look at this, we get negative 1x. If we had gotten positive 1x instead of negative 1x, you just flip the signs, okay? And so meaning make the 5 positive and then 3 negative, then set each of these parentheses equal to 0, and you would get over here x is equal to, you'd have to plus 5 and then divide by 3, it's 5/3. The other answer would be, or x is equal to negative 3/2. Set 2x plus 3 equal to 0, you're going to subtract 3 and then divide by 2. So factoring to solve is because you cannot solve these algebraically. You've got to solve them by factoring and making them into two things that multiply to make 0. And so set each factor equal to 0 to solve your answer. So let's try the next one. It could be 8 times 1x, or it could be 2x and 4x. I think it's 2x and 4x. And there's really not necessarily a way to tell. You just kind of have to try things. Now to get to 9, multiplying, you could do 1 times 9 or 9 times 1, or you could do 3 times 3. And either way, you're going to need two negatives to get to a positive number because the middle number is going to be negative 18. So if we try negative 3 and negative 3, I think that's going to work. So let's check it out. 2 times 4 is 8x squared. Negative 3 times negative 3 is positive 9. Look at our rainbow. Here we go. We get negative 6x and negative 12x. Look at us, negative 18x. Set each factor with a letter into it equal to 0. You get x is equal to 3/2. And over here, it would be x is equal to 3/4. And so those are both our answers. Now, one thing I do want to talk about would be two kinds of questions that are not on here, but they're assumed you know them, but I feel like you kind of could use a little review, okay? And they're on your homework, and then we should talk about the word problems as well. Okay, well, the thing is this. If you had 8x squared minus, I don't know, 10x, do you know how to factor that? Equals 0. Again, we can only solve like with square root property really if there's just x squared or x, but not both. And so this has both. So if I say, hey, solve by factoring, do you know how to factor this? Okay, and so the thing is, a lot of kids overlook GCF. Well, the GCF between these two factors would be 2x, and you're left with 4x minus 5. You see that? GCF factoring counts, and you've got two factors that are multiplied to make that answer. And so if you set each of these factors equal to 0, the factors that have letters in them, you can solve to find out what x would be. That's a minus 5 equals 0. So on the first one, 2 times what makes 0? Well, x equals 0. 2 times what makes 0? Well, x has to be 0. And then this one you plus 5 and then divide by 4. So x is equal to 5/4. So those are our answers. So GCF type of factoring is really a valid and overlooked type of factoring. Another one I would love to suggest would be this. If you've got 4x squared minus 9 equals 0. Okay, do you know how to factor that? And if you look at it, you're like, I don't know. Well, try it. The product of the first has to make the first. So 2x times 2x makes 4x squared. And then to multiply to make negative 9, you need a negative 3 and a positive 3. Those are options. We'll check the rainbow and see if it works. Well, the product of the first makes the first. The product of negative 3 and positive 3 is negative 9. Your rainbow will give us 6x minus 6x. And guess what? That's 0. There is no middle term. Okay, and so if you notice you have the difference, the subtraction of two perfect squares. Yes, 4 and 9 are perfect squares. It's going to be the conjugates, the square root conjugates that will be the answer. So set each factor equal to 0, and you get x is equal to 3/2. This will be x is equal to negative 3/2. So difference of two squares absolutely is a valid type of factoring. I just don't want you to kind of forget that. Let me get rid of him. The number 7 does not factor down here. So don't cry about it. If it doesn't factor, notice we can use the square root property on this one. Why? Because it has x squared but not x. And so if you minus 25 from both sides, you get x squared is equal to negative 25. How do you get plain old x? We'll square root it. How do you square root a negative? Well, you use I, okay, square root of negative 1, which is I. So it'd be plus or minus 5i is what x is. So I want you to be alert to, if it was the difference, the subtractions of two perfect squares, then you could factor. If this was a x squared minus 25, you would get x plus 5, x minus 5. That would be perfectly fine. But since it's plus, you can't factor it, and so you've got to solve it another way. So I want you to realize that's kind of the story. If it has 4 terms, you're going to factor by grouping by taking out the greatest common factor of the first half. And of the second half, take out a negative 9. You're left with x plus 4. If the leading term of a group is negative, take out a negative. And then your common factor is x plus 4. And then your second factor is x squared minus 9. And that equals 0. Now, my question for you is, do you see that this is x to the third? Well, how many answers are we going to get? Well, 3. Square roots or not square roots, square quadratics, you should get 2 answers. Okay. When you have a cubic, you're going to get 3 answers. When you have a quartic, you're going to get 4 answers. Now, do you see that one of these factors further? Well, this one here does. How so? What's the difference of 2 squares? Is x plus 3 and x minus 3. And so then you've got x plus 4. If you set each of those factors equal to 0, you're going to get x equals negative 4, x equals negative 3, and x equals positive 3. Now, if you had not seen that this factor is further, that would be okay. You take both these factors and you set each one equal to 0. So if you x plus 4 equals 0, you get x equals negative 4. And the thing is this, if you set x squared minus 9 equal to 0, you plus 9 to both sides. Well, if x squared equals 9, what does x equal? When you do the square root property, you need plus or minus. So x is equal to plus or minus 3. Okay, so that's an important thing. You're going to get the answer either way. It's just remembering, hey, cubics have 3 answers. Can you find them? And will you remember when you do the square root property to do plus or minus on it? Okay, over here, take out the GCF. You're left with x squared. You're left with x minus 3. Take out 16. You're left with x minus 3. Again, move the 48 to the side, so it'd be minus 48. And then your GC, or your common factor is x minus 3. Your other factor is x squared plus 16. Does that factor further? The answer is no. X squared plus 16 does not, because it's the sum of 2 squares. So you set each factor equal to 0 and solve. So this would give you x equals 3. And what would this give us? Well, x squared plus 16 equals 0. You minus 16 from both sides. You get x squared equals negative 16. Take the square root of negative 16. You get x is equal to plus or minus 4i. Okay, so remember when you do the square root property, you get that. One other connection I really want to make with you is this. Remember, in the previous chapter, in our previous quiz, you guys had to solve by graphing and finding the x-intercepts, right? Well, if you did graph number 7, I'm going to switch colors just so it's not a little bit less of a hideous mess. If we graph this, you would have y is equal to x squared plus 25. What does the 25 do to my graph? I've got a parabola. The plus 25 raises it up 25. So where does it cross the x-axis? It doesn't. Notice there are no real solutions to the problem number 7. So as evident in the graph of it, it never crosses the x-axis. It doesn't mean there aren't solutions. They're just not real. Okay, and so if you look at like the next question, number 8, and you graphed that, yes, you can solve this by graphing. Okay. Well, if you put a y here, and even if you put it in your calculator, you would notice it crosses the x-axis at -4, -3, and +3. Is this going to look like a parabola? Well, no. It's going to cross the x-axis at all the real solutions, okay? And that's what your graph will look like, okay? You will see the zeros or the real solutions to an equation or function when you graph it and you see where it intersects with the x-axis. Look at the last question. If you look at this one, okay, it's going to cross at 3. Where else is it going to cross? Well, it's not, because how would it cross at 4i? So your graph's going to cross here, and it's going to kind of do some other bendy things, but it's never going to cross the x-axis because the other 2 solutions are imaginary. The one above it, if you graphed this problem number, I don't know what it's called, number 6, it's going to cross at 3/2 and 3/4, okay, which again, decimal, whatever. But if you graph this with a y here, you would notice it crosses at both those values, those decimal values, because there's 2 real solutions. Quadratics have 2 solutions, okay? Sometimes they are duplicates, and we'll talk about that moving forward, but cubics will have 3, and quartics would have 4. But if you look at their graphs, you would notice where they intersect the x-axis, that's going to be their real zeros. So thank you for listening. Okay, bye.